Hello, we are 穿越省林竹顾丽君章. We will present our term project in next few minutes. The content will follow introduction, data preprocessing, model selection, diagnostics, and visualization. AmesHousing in our package was used as the dataset. It describes housing price in Ames Iowa. There are 2930 observations and 82 variables, including sale price and geoinfo. Sale price will be used as the response. For data preprocessing, first we summarized each variable. If the same value, including NA, exceeds 80%, we delete it. So in this step, 4 variables were deleted. For the remaining variables, we handle with NA. If NA means no feature there, place it with none. If NA is possibly a missing data, delete it for categorical variables, or replace it with median for numerical variables. Here's the example. Electrical is a categorical variable. After summarizing, we found there is one NA, so we delete the corresponding observation. Lot frontage is a numerical variable. There are almost 500 NA, so we place NA with median. After data processing, we have 2880 observations and 77 features including geoinfo, and there are 42 categorical variables and 35 numerical variables.
Then we start to do the model selection. We do the variable processing first. We do the collinearity for our 35 numerical variables using the criteria as 0.9, and in this case, no variable is deleted. After that, we do the transformation of our outcome by Box-Cox transformation. The lambda for the maximal likelihood is 0.22, thus we use the lambda equals to 0 in our case. That is, no change for outcome is needed. After that, we start to use the step function for variable selections. Both AIC and BIC method is used, and our largest model is an additive model since there are too many turns in the interaction models, so the step code will be inefficient for the interactive model. And for both two methods, there are 3 models respectively, forward, backward, and the both model. It is observed that the both model is the same as the backward models, and the variable selected by BIC method is much less than the variable numbers in AIC method. From this step function, we can have 6 models in total, and we can observe some common numerical variables and categorical variables in all the 6 models, and they will be further studied in our visualization part. Then we use ANOVA to do the model selection. From the ANOVA result, we find the model 2.1, that is the forward model from AIC method is our best solution. Then we start to do the diagnostic for our model. 1156 high leverage points is observed, but we keep them. And 15 outliers is fine, and we delete them. The figure shows the Cook distance for our model, and there are 12 high inferential points with Cook distance larger than 1, and we delete all of them and get our final model, that is model 4. Then we start to do the assumption checking. First, we use the fitted and residue plot. This plot can be used to check for the linearity and constant variance assumption. We find the residue roughly centered at 0, suggesting the good linearity of our data, but no uniform spread of the residue along fitted value, which means we should reject the constant variance assumption. Then, BP test is also needed to check for the constant variance assumption because it is a more formal test. From the BP test, we find the p-value is less than 0.05, so we reject the null hypothesis. indicating the constant variance assumption is not satisfied. Then, normality assumption should also be checked. We find in the frequency various residue plot, there is a rough bell shape but has a very sharp peak, so it is not clear whether the model satisfies normality assumption. A more powerful tool, that is QQ-plot and Tableau weak test, is needed to check these assumptions. Points of the plot do not perfectly follow a straight line, suggesting that the error may not follow a normal distribution. The test result from the Tableau weak test give us the similar conclusion, that is, the p-value is less than 0.05, suggesting that only a small possibility that the data sample is from a normal distribution.
The last part is about the data visualization, and we use Tableau to create the user interface. First, we choose the sales price versus the year of build. Judging from the plots, sale price generally increases when time goes by, but the slope will change based on the time. If we change the slider here, we notice that the slope becomes steeper for the latest years, which means that the house sales price will increase more in the latest years. Then we use a single scatter plot for sales price versus the first floor area. The figure shows that there might be a linear relationship between sales price and first floor area. We also add the trend line here, which shows the p-value is less than 5% and the r-square is 0.4, which means the first floor area might be a significant variable for the sale price prediction model. As for the individual categorical variable, we choose neighborhood. The sales price in different neighborhoods are different. We can easily see the median and the lower and upper confidence interval for each neighborhood. It's obvious that the sales price and its distribution in different neighborhoods are different, so we could assume that neighborhood is a significant categorical variable for sale price analysis. Then we aggregate the sales price with the first floor area and different neighborhood. There are too many neighborhoods, so we could randomly choose part of them. We could see that in different neighborhoods, the linear relationship between sales price and the first floor area are different, so these two variables should all be included in the prediction model. As for multiple categorical variables, we do a Mosaic plot for sales condition, basement exposure, and kitchen quality. We could notice that the sales price under different sales condition, basement, and kitchen quality are different, and the size of each square is proportional to the average sales price, while the shade of color is based on the number of observations, which means that the largest size of the square means it has the highest average sales price. We could notice that if you want good basement, excellent kitchen, and abnormal sales condition, you will afford the highest sale price. We could also notice that this condition will have the most frequency houses. If you don't care about basement and not very much about kitchen and you want the sales condition to be normal, you will have the most choices because they have most houses here. Last, we show the map of the average price in different neighborhoods. We notice that the size of the points and the shade of the color are all proportional to the average sales price. We notice that this neighborhood has the highest average sales price, while the smallest one has the lowest sales price. After making this
data visualization, we found 3 findings. First one is that we could do some prediction based on the sales price in the previous years and forecasting the next few years' sales price. Based on the trend line and forecasting in Tableau, we have 95% confidence to say that the average sales price will stay stable around $260,000 in next 5 years. And the second result is that we could provide some recommendation for location choice for economic sales price. Different neighborhood may have different sales price, and they may have different sensitive to the first floor area, which means that if you want to have a bigger house, you may need to pay more in some area. The last one is that we also need to consider about the house availability and the house condition. You could trade off between the basement and kitchen condition to have the cheaper sale price. There is also some constraints for the number of houses available in different conditions.